Welcome to the first of several examples of finding the partial fraction decomposition of a given rational expression. Partial fraction decomposition is a method for writing a given rational expression as a sum or difference of rational expressions that are simpler than the given expression, and this is often helpful when integrating in calculus. Before we start, we need to make sure that the degree of the numerator is less than the degree of the denominator. For example, here we have 12, which is degree 0, and in the denominator we have degree 2, so we've satisfied the first condition, so we can go ahead and perform partial fraction decomposition. If the degree of the numerator was not less than the degree of the denominator, we'd have to start by performing long division. So the first step will be to factor the denominator completely, so we would have 12 divided by x squared minus 9 is a difference of squares, so we'd have a factor of x plus 3 and a factor of x minus 3. Notice in this case, our denominator contains two distinct linear factors, which means we'll have two fractions in our partial fractions, where the first fraction will have a denominator of x plus 3, and the second fraction will have a denominator of x minus 3. Now, if we had repeated linear factors or quadratic factors in the denominator, it would affect how we set these fractions up, which we'll see in future examples. And again, because we have linear factors in our denominator, that means our numerators will be constants, which we don't know the values of right now, so we'll use the variable a for this numerator and b for this numerator. So we're using a single variable for the numerators because we have linear factors in the denominator. And now if we can find the value of a and b, we'll have our partial fraction decomposition. So to solve this equation, we're going to clear the fractions by multiplying both sides of the equation by the least common denominator, which would be the quantity x plus 3 times the quantity x minus 3. Notice on the left side, when we multiply, x plus 3 over x plus 3 simplifies to 1, and so does x minus 3 over x minus 3. So we're left with 12 equals, and on the right side, for this first product, x plus 3 over x plus 3 would simplify out, leaving us with a times the quantity x minus 3. And then for the second product, notice how x minus 3 over x minus 3 simplifies to 1. So we'd have b times the quantity x plus 3. This equation here is called the basic equation, which we want to solve to find the value of a and the value of b. And there are a couple ways to solve this for a and b. One way is to multiply out the right side, combine like terms, and then set the coefficients of like terms on the left side of the equation and the right side of the equation equal to each other to form a system of equations, or, which we'll do in this example, we can select convenient values of x and then perform substitution in order to find the values of a and b. When I say convenient values of x, we're going to pick values of x that make the factor x minus 3 or the factor of x plus 3 equal to 0. For example, if we select x equals 3 and perform substitution, that would give us the equation 12 equals, well, if x is equal to 3, we would have a times 0, which is equal to 0. So this is eliminated, so we have b times the quantity 3 plus 3, which would be 6b. Divide both sides by 6. We know that b must equal positive 2. The other convenient value of x would be the value that makes x plus 3 equal to 0, which would be x equals negative 3. So we'll substitute negative 3 for x, which would give us the equation 12 equals, this would be a times the quantity negative 3 minus 3, or negative 6a. And here, negative 3 plus 3 is 0, b times 0 is 0, giving us this one-step equation. Divide both sides by negative 6. And so we have a equals negative 2. And now we'll substitute the values of a and b into our fractions here on the right, which will be our partial fraction decomposition. Notice that a would be negative 2 and b would be positive 2. So we could leave it like that, but it'd be more common to write the positive fraction first. So we found that 12 divided by the quantity x plus 3 times the quantity x minus 3 is equal to, again, we're going to put the second fraction first. B is positive 2. So we have 2 divided by the quantity x minus 3. And then because a is negative 2, instead of writing plus negative 2, we'll write just minus 2 divided by the quantity x plus 3. This would be the partial fraction decomposition of our rational expression. Meaning if we subtracted these two fractions by obtaining a common denominator, we would end up with the fraction on the left. Okay, we'll look at several more examples in the next few videos. I hope this was helpful.